Okay, guys, in this video, we are going to look at velocity, speed, and acceleration of a particle given its position. So position is a vector, and for each fixed value of t, think of t as time. So for each time, the particle is somewhere, right? In this case, on the plane, because there are only two components. So this is going to be 5t minus sine 4t, and 1 minus cosine 4t. That's the position. So this is called the position vector, which is the location of the particle at a time t. Velocity is also a vector, and it is defined as the derivative of the position vector. What that means is basically we're taking the derivative of each component. And of course, velocity is a vector. Okay, that's velocity. Okay, that looks a little bit weird. Okay, something like that. Okay, finally, acceleration is a derivative of velocity. So that would be v prime. It's also a vector. You can also say that that's a second derivative of the position vector. So that would be acceleration. And finally, what about speed? Well, the speed is really, you can sometimes people use velocity and speed interchangeably. Well, actually, that's not quite right because velocity is a vector. So it's not just a magnitude, but also direction. Speed, sometimes what they write is just v of t without the arrow, indicating that it's a scalar. So it doesn't have a vector, right? It doesn't have direction. But here, I guess they denote it by s of t. Either way, it's not a vector. So for each value of t is a number, and that is just the magnitude of velocity. So we are taking the magnitude of the velocity vector. We will also need to simplify it. All right, let's first take the derivatives. So derivative of 5t, just like any line, remember, derivative of a line is its slope, so that would be 5. And since we're adding or subtracting, we just do each part separately. Then it's going to be minus. Okay, hopefully you remember I told you to memorize derivative of sine is cosine. Sine is cosine. So this becomes cosine. Also 4t, so the argument doesn't change. And then derivative of 4t itself by chain rule is a 4. So that goes in the front. Okay, so that's velocity. The x component. Let's do the y component. So 1 is a number. Derivative of any number is 0. So again, remember, if the number is added or subtracted to a function, then it becomes a 0. But if it's multiplied, then you keep the number. In this case, it's added or subtracted, so that's going to be 0 minus. Derivative of cosine is actually negative sign, so that'll make this a plus sine 4t. And again, because of chain rule, there's going to be a 4 in the front. Okay, so that's finally the velocity. We got that part. The acceleration is one more derivative. So let's do it again. Derivative of 5 is 0. Derivative of cosine is negative sign. So this minus will turn into a plus. Another 4 will come out from the chain rule. So it'll be 4 here as a constant multiple, which you keep, right? Because it's multiplied, not added. And then another 4 comes out from the chain rule. So this will be 16 sine 4t. Now, of course, the plus sign is not needed here. Let's do this one. So again, 4 is a constant multiple. We keep it. Another 4 comes out from the derivative of the sine 4t. So that'll be 16 cosine 4t. Okay, now what's left is finding the speed. The speed is the magnitude of velocity. So let's go back and find the magnitude. Actually, I'm going to put the square root at the end. So at this point, I just want to do velocity squared. So I don't have to carry that big, huge square root. So that's just going to be, I said velocity squared, speed squared. Okay, 5 minus 4 cosine 4t. We square that, and then plus 4 sine 4t, square that. Okay, what do we see happening here? All right, first of all, we've got an expression that looks like this, a minus b squared. Now, that is not a squared minus b squared. That is not the formula. If you do not remember it, then just FOIL, like put a minus b multiplied by a minus b, and you will see that the formula is correct. But the formula looks like this, a squared minus 2ab plus b squared, because these two minuses will turn into a plus. So what I'm doing here is this is my a, subtract, and this is my b. Okay, so let's use the formula. Okay, so the formula says a squared, so 5 squared is 25, minus 2ab, okay, we got that term, plus b squared. So plus, so when you square 4 cosine 4t, what happens? First of all, 4 squares, and that's 16. And then cosine squared 4t. Okay, so we're not quite done because we have this one last term. And that term is just 4 sine 4t squared. So 4 is squared, that's 16. And sine is also squared. So if you're wondering, why the heck did I have to do this? Why can't I just put this as a final answer? Well, because they want you to simplify it. And the simplification is going to come out of you noticing something. Look at this term and compare that to this term. So the first trigonometric identity that everybody knows is that sine squared plus cosine squared is 1, right? It's because it's a unit circle. Okay, so we got 2 times 5 is 10 times 4, 40. So this would be 40 cosine 4t. But here, if I take out the 16, I see my favorite identity, cosine squared of something plus sine squared of the same something. They have to match, and they do. This right here, that's just equal to 1. So isn't that nice? So that is just going to be 1. So this becomes 25 minus 40 cosine 4t plus, well, that one's 1, but there's a 16. And now we can combine, right? We can combine the 25 and 16 into one term. So that becomes, well, what is 25 plus 16? This is going to be 41, right? Isn't it? Minus 40 cosine 4t. And remember that I did not want to carry around that square root, right? The square root was not something that I wanted to carry. So I'll just put it at the end. All right, so let's see. So this is going to become square root of 41 minus 40 cosine 4t. So let's see if that's right.